Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So in this video, I am going to tell some more problems on first order linear equations. So I am going to solve some more problems based on the Lagrange's equation and using the method of grouping and method of multiplying. So already we know this information. What is the Lagrange's equation? Just I want to give some outlines here. The Lagrange's equation is in the form P into P plus Q into Q equal to R, and P comma Q comma R are functions of X, Y, Z. The general solution of this Lagrange's equation is f of u comma v equal to 0 or phi of u comma v equal to 0. So here u is the solution and v is the second solution. That u is u equal to x comma y comma z equal to c1 and v of x comma y comma z equal to c2. So we have to find two solutions here, u and v. After then we can write the final general solution. So how we can solve this? So just now I told you we are using two methods, that is method of grouping and method of multipliers. So some of the problems here we can get the two solutions from only method of grouping. We can get the two solutions from only method of multipliers. And some of the problems you can get one solution from method of grouping and one solution from method of multipliers. So these type of problems are there. So we have to solve those problems. We can understand the question carefully. Based on that we can solve if you know the concept clearly. So I am going to explain the problems. You can see now. See the question. Find the general solution of the partial differential equation. So we have to find the general solution for the given partial differential equation. What is the partial differential equation? Y square u into p plus x square u into q equal to y square x or xy square. This is the given partial differential equation. So first we are comparing this equation with the Lagrange's equation. So comparing with capital P into small p plus capital Q into small q equal to R. So what is the capital P value? That is y square u. So capital Q is x square u. Capital R is y square x. These are our P, Q, R. So now after comparing with the Lagrange's equation, we are going to write the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. So here in place of z in the solution we are having u. So that means we can write here dx by p equal to dy by q equal to du by r. So based on that we are substituting the values. P value is y square u. So we wrote here dx by y square u. Q value is x square u. So dy by x square u. Next R value is xy square r y square x. So du by xy square. This is our auxiliary equation after replacing the PQR values. Now we can use grouping method. If it's possible, we can get the two solutions from the grouping method only. So we have to observe the auxiliary equation. Based on that, we can decide can we get the two solutions from the grouping method or not. If grouping method is not possible, then we will move to multipliers method. So we can observe here dx by y square u, dy by x square u. Take here, first I am taking first two members. That means here I am taking the grouping method. So what are the first two members? Dx by y square u equal to dy by x square u. So these are the first members I am taking. So I can take this one as the first one, second member, and third. I am taking here first two members. Dx by y square u equal to dy by x square u. U will be cancelled here. So x square, taking cross multiplication, x square dx equal to y square dy. Now integrating on both sides, integral x square dx equal to integral y square dy. So integral x square is x cube by 3. Here y cube by 3 plus some constant. So I am writing this one as x cube by 3 minus y cube by 3 equal to c1. I can write this one as x cube minus y cube equal to 3c1, means I can write this one as constant. Say this is my first solution, that is so u equal to x square minus y, x cube minus y cube equal to c1. This is my first solution, that is u equal to x cube minus y cube. Now I am going to get second solution. Now, so I got first solution u equal to x cube minus y cube. Now I am going to get the solution. So here I am taking first member and third member. What is the first member? Dx by y square u equal to du by xy square. So here y square will be cancelled. So I am doing the cross multiplication here. X dx equal to ut, x dx equal to ut. So integral x dx equal to integral ut. So what is the integral x is x square by 2 equal to u square by 2 plus some constant c2. So you can write x square by 2 minus u square by 2 equal to constant. So finally this is x square minus u square equal to 2c2, that is c2. So this is x square minus u square equal to c2. So this is the second solution, v equal to x square minus u square. So x equal to v equal to x square minus u square. So this is the first solution and this is the second solution. So now I got two solutions from the grouping method. So now I am going to write a general solution. So general solution is f of u comma v equal to 0. So here the general solution is f of u comma v equal to 0. What is the u? F of u is x cube minus y cube, comma v is x square minus u equal to 0. So this is our general solution. So what they are asking, find the general solution of partial differential equation. So this is the general solution of partial differential equation. So this is the way to solve the problem. So some of the problems we are having here said. So what is the variability is there? We can calculate according to the given procedure. So no need to confuse. Excuse me. Now I am moving to next problem, that is solve x z into p plus yz into q equal to xy. So that is xz into p plus yz into q equal to xy equal to xy. Now I am comparing this one with this equation, that is p into p plus q into q equal to r. So here this is the capital P value and this is the capital Q and this is the R. Now P is xz, Q is yz and R is xy. So therefore, the auxiliary equation or subsidiary equation is dx by p equal to dy by q equal to dz by r. So here I am going to replace p, q, r values. So dx by xz equal to dy by yz equal to dz by xy. So now dx by xz equal to dy by yz equal to dz by xy. So now I am going to take first two members. So first two members means dx by xz. This is the first one. And is equal to second one dy by yz. So now z will be cancelled. So dx by x equal to dy by y. So now I am going to integrate on both sides. So dx by x equal to dy by y. Now integrating on both sides. Integrating on both sides. So integral dx by x equal to integral dy by y. So log x equal to log y plus some constant. So both terms are log, so that's why I'm taking constant in terms of log. So I can write this one as log x minus log y equal to log c1. Now log a minus log y. So log a by y. So log x by y equal to log c1. So finally this is x by y equal to c1. This is my first solution. So here u equal to x by y. This is my first solution. Now I am going to calculate the second solution. So here, so u is x by y. Now I am going to solve second solution by using the same method. So what is that? I am taking last two numbers. What is the last two numbers? Second and third. So dy by yz equal to dz by xy. Now y will be cancelled. So now here dy by yz equal to dz by xy. So here we will take here dy by y. So here y will be cancelled. Finally this is dz by, you can observe here one more step, dy by yz by dz by xy. So this is the second member yz and xy. So y will be cancelled here. Okay. So here dy by z equal to dz by x. So here dy into x equal to dz into z. But I won't integrate here because it's not in the form of variable separable. So I am going to substitute the value here by using the solution, that is already I got x by y equal to some a solution. You can observe here x by y. So here from this I am writing x equal to ay. So from the first solution, writing x by y equal to some constant. So x equal to ay I can replace. So dy into ay equal to dz into z. Now I got variable separable form. So I can integrate. So integrating on both sides. Now integral a by dy equal to integral z dz. So a is the constant, integral y is y square by 2 equal to integral z is z square by 2 plus some constant. Here before I taken a, so now I am taking b. So here, and I am do multiplying with a here. So this one is 2ay square equal to 2z square plus some constant. So 2ay square minus 2z square equal to 2b. So now taking 2 common, ay square minus z square equal to 2b. So 2 will be cancelled here. Finally, ay square minus z square equal to b. Now what is the a? A is x by y. So x by y into y square minus z square equal to b. So here y will be cancelled. Finally, xy minus z square equal to b. So this is my second solution, what you are seeing. So this is the solution B. Solution u is x by y and x by y. So now I am writing the final solution. So that is general solution. General solution is f of u comma v equal to 0. That implies u is x by y. Already calculated. V is xy minus z square. These are the solutions we are going to replace here. F of x by y comma xy minus z square equal to 0. So this is our general solution. This is our general solution after solving this equation. So this is the way to solve the problem. Find the integral surface of x into y square plus z into p minus y into x square plus z into q equal to x square plus y square into z. So here, again observe, which contains the straight line that is x plus y equal to 0 and z equal to 1. So first of all, we have to take the equation that is x into y square plus z into p minus y into x square plus z into q equal to x square plus y square into z. This is our given equation. So first of all, comparing with the Lagrange's equation, that is capital P into P plus Q into Q equal to R. So what is the capital P? Well, capital P is x into y square plus z. Capital Q is minus y into x square plus z. Capital R is x square plus y square into z. Now I am going to do the solution. So now I am keeping in the auxiliary equation, that is x by p equal to dy by q equal to dz by r. So what is the p value? So x into y square plus z. So dx by x into y square plus dy by minus y into x square plus z. dz by x square minus y square into z. So after that, now I am using the multipliers method to solve this problem. So what is the multipliers method? Already we know that. First we have to choose the multipliers L, M, N according to the condition. L into dx plus M into dy plus N into dz should be 0. Then we can integrate this one. So L dx integral m dy plus integral n into dz, so equal to some constant. So this is our solution. So according to that method, I am taking here set of multipliers. We can observe If we got 0, then we can set that one as a multipliers. Now I am taking first multipliers x, y and z. So first I am calculating here numerator x into dx plus y into dy plus z into dz. Now I am going to multiply here denominator with x. So already x is there. With x I am multiplying. So x square into y square plus z plus already minus is there. So minus y square into x square plus z plus x square plus y square into z square. Now I am doing here. This value is x square y square minus z x square minus y square x square minus into plus minus y square z. Next plus here x square z square plus y square z square. So here I multiplied with x. So x square y square. Next z into x square. Here x square z is there. X square y square plus into minus minus y square z. So here I got x square z square minus y square z square. So now I am taking here x square will be cancelled. Next here x square z square. So here x square z here z x square is there. Here y square z here y square z is there. So how we can get this value is 1 we have to take. Then it will be, so here I will get x square z and y square z. So here x square z, here x square z will be cancelled. So here y square z, here y square z will be cancelled. Finally x dx plus y dy. So here z value taken 1. So y dy plus dz by 0. So these are x, y, 1 are the multipliers. Now I am going to integrate that one. So integrate x dx plus integral y dy plus integral dz equal to 0. So this one is x square by 2 plus y square by 2 plus z equal to some constant. So I am writing this one as x square plus y square plus 2z equal to some constant. So finally solution is I got here x square plus y square plus 2z. So this is my first solution by using the multipliers method. Now I am going to use another set of multipliers. So that is 1 by x into dx plus 1 by y into dy plus 1 by z into dz by, so 1 by x into here you can see 1 by x into y square plus z minus 1 by y into x square plus z 1 by z into z x square minus plus y square. So now here z will be cancelled, y will be cancelled, x will be cancelled. Finally this is y square z minus x square minus z plus x square minus plus x square minus y square. So here I got the value z plus z minus z minus x square plus x square minus y square plus y square. If I got here this one, so then only I can cancel and I can take this one as a multiplier. So So x square minus y square into z. Here this value is x square minus y square into z. Here this value is minus 1. So based on that, this is minus 2z. So now I got the solution to that is 1 by x into dx plus 1 by y into dy plus 1 by z into dz equal to 0. So integral 1 by x dx plus integral 1 by y dy plus integral 1 by z dz equal to some constant. So now log x plus log y plus log z equal to some c2. So log x, y, z equal to, I'm taking both sides off, so log c2. So finally x, y, z equal to c2. This is my second solution. U is x square plus y square plus 2z and v is x, y, z. So finally the general solution is x square. First solution is x square plus y square minus 2z equal to some constants you are not if you can take. And second solution is x, y, z equal to v. So now what they are asking in the question, they are asking to find the integral surface of that equation. So first, what are the straight line equations they given? I am writing here. The straight line is x plus y equal to 0 and z equal to 1. X plus y equal to 0 and z equal to 1 now. So now I am going to replace here in this equation, that is x square plus y square minus 2 into z is 1 equal to some constant. So x square plus y square equal to minus 2 equal to a. So now we are going to use in this x, y, z equal to b, z equal to b. So x, y into 1 equal to b. So this is the second solution. Now I am going to use this one to simplify this equation. So I am doing here a plus 2b. So what is the a value? X square plus y square minus 2. Next one is plus 2xy. I can write it as x plus y whole square minus 2, that is equal to minus 2 because this value is 0. Already I know this. So finally I got here x square plus y square minus 2 into z value is 1 plus 2xyz plus 2 equal to 0. So this is our required surface. So this is the way to solve the problems differently based on the given question. So you can do more problems to get a better idea about the problem. You can observe this, then you can enjoy the procedure of it. So these are the methods and these are the way. This is the way to solve the given equations by using method of grouping and method of multipliers and two solutions together to know about the general solution of partial differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.